Decision making with multiple uncertainties. Quite often, we have to make decisions in the presence of multiple uncertainties. So let's consider a project. Gengen Pharmaceuticals believe that a particular variant of vitamin E that they had developed has the potential for a new drug for treatment of diabetes, thrombosis, and high cholesterol. However, they can only invest in one of these projects. The issues facing Gengen are: 1. Uncertainties associated with the success of preliminary tests. 2. Uncertainties of the FDA approving the new drug. And of course, there are also uncertainties of revenues. The cost of pursuing these projects is considered to be the same for all of them. Preliminary tests would cost $2.5 million, and the FDA approval process would cost another $500,000. The marketing department has arrived at potential revenues from these projects. Here too, there are some uncertainties. There is a possibility of high revenue, as you can see from the table, and a possibility of low revenue. The question Gengen needs to answer is, which project should they pursue? Now, this could be 3 sites that project managers are looking at, or 3 bids. But in this case, we are looking at 3 projects. This type of problem is ideally suited for decision tree solutions. Since we do not know what the probabilities are, we can start with the 50-50 assumption for all uncertainties, and then study the impact of such assumptions on the final decision. So let's draw the DT sketch and develop the Excel model, and then we'll plot the D-zone map and identify the various regions. Finally, we can modify the model to study the uncertainties. Here we have a decision tree sketch. We have to make a decision. Should we go with thrombosis, high cholesterol, or diabetes? Let's look at the thrombosis case. There's a chance that the preliminary test would fail and we would have to abandon the project, or we might succeed at the test. If we are successful, then we have to go for FDA approval, where we might be approved or we might be denied, in which case we have to abandon. And if we get approval, there is the possibility of high revenue or low revenue. We have similar paths for the other 2 projects as well. I will not draw them because it will clutter the picture. So the next step is to build the decision tree on our Excel model. When we launch the Excel decision tree app, this is what we get: 1 decision node and 2 terminal nodes. If you recall from our decision tree, we had 3 projects: thrombosis, high cholesterol, and diabetes. So let's add another branch. Add a new branch and say, okay, it's very simple. First branch is diabetes, throm, and choles. So these are our 3 projects. And as you recall, all of these have uncertainties. So let's create an uncertainty here, which means we create a probability node. It's very simple. And the first doubt is the preliminary test. Prim test failed. And diabetes, prim test success. As you can see, we now have our first probability node and the 2 outcomes. If we have this success, we must go for the FDA test, which also has uncertainties. So we create a probability node. Here we have diabetes FDA approved, diabetes FDA denied. If we do get approval, we can proceed to the next level, which is uncertainty of revenue. So we can again convert to a probability node. And we now have our high revenue and low revenue. So this is the model for the first leg. In the interest of time, I have already completed these diagrams. So let's proceed. Here we have the complete model, and I've also added the terminal values. How did I get the terminal values? I created a table with all the values. Here are the terminals. Here are the activities, and here are the terminal values. We are going to look at the probability of our preliminary test being successful. So for diabetes, we will set it to the orange variable. For thrombosis, we will set it with the plum, and for cholesterol, we will set it to the olive. We go to the zone map, and we simply say clear chart and draw. One button, and you see a zone map. This is known as the triple point. So now we have our three zones clearly defined. If the original assumptions are 50%, then we should go with the diabetes project. However, you can see here, the decision is very sensitive to our assumption. Note that this is a three-dimensional diagram, but you can only see two dimensions here. The third dimension is behind this page. For example, if I change cholesterol from 50% to 60%, I have a new diagram. You can see now it's very close. And if it goes to 70%, the decision is for cholesterol. So the first thing to note is, by changing the probabilities using these three axes, we can study the impact of these changes on our final recommendation. This diagram represents the case where the preliminary test is involved. Now, what about the uncertainties associated with the FDA approval? Let's go back to our tree, and we will set the probabilities to the FDA approval. Now let's go to our zone map and redraw. You see an entirely different diagram. As you can see, if the FDA approval is the uncertainty, we should go with diabetes, but we have a very small change here happening. Okay, so we go back here. Let's make revenues our focus. So we put in here. Let's go to the D zone map and plot. Very interesting. Now we do not have three zones, but we only have two zones. This diagram tells us, under this scenario, we should not concern ourselves with the cholesterol project. The decision is only between thrombosis and diabetes. However, let's see what happens if the probability of cholesterol goes up from 50% to 60%. Very interesting. Suddenly, cholesterol comes into play. You can see the impact of changing the probability of high revenue within cholesterol. What happens if you change it to 70%? As you can see now, the zone has expanded more. Still, the decision is, of course, diabetes. So this type of diagram, what we call the zone maps, allows management to understand how your decision is affected by the various uncertainties. Here we have the three decision zone maps. The first one is considering the uncertainties of the preliminary test. The second is about FDA approval, and this third one is about revenue uncertainty. As you can see, all three of them favor diabetes. In this case, the company should concentrate on exploring the viability of this drug for diabetes. Now, of course, this decision is based purely on uncertainties. We cannot forget other criteria that drive such a decision. To deal with multi-criteria decision making, we have to resort to a different model. Some of you may have looked at the revenue picture for cholesterol, diabetes, and thrombosis, and then concluded that the diabetes actually had the highest revenue both on the high side and the low side. So naturally, if everything else is equal, then diabetes is the obvious choice. And that's a valid comment. However, there are many instances when the problem is not as simple. Here is an example where you are trying to source raw materials from one of three countries, Liberia, Congo, and Angola. And you have some political uncertainties that could disrupt contract fulfillment. Let's look at the data. Here we have the probability of an event happening and the associated consequences. As you can see, you have 19 data points. Based on this data, where would you source from? You can do some simple multiplication of the expected value and make a conclusion. But these are all assumptions. There are uncertainties. So how do you navigate through these uncertainties? If as a CXO, you are presented with this data, there is no way you can make a defensible decision relying on common sense, logic, and gut feel. You have to model this type of problem. Take a look at the decision tree diagram. Here we have the decision tree sketch. Here we have the corresponding decision tree and the associated D-zone map. Under the given scenario, Angola is our choice, and there's some degree of safety here of our assumptions. If you doubt the assumptions, you can certainly look at the uncertainties with the aid of a map such as this. That is why we say D-zone maps are invaluable. Lee Iacocca, the president of Chrysler Corporation, once said, "The greatest obstacle to discovery is not ignorance, it is the illusion of knowledge." Sadly, most of us believe that our common sense, our logic, our gut feeling, and intuition is more than adequate to solve any problem. Sadly, this is an illusion.